So in this video we're going to look at how to store negative numbers in binary. Before we get started, it's just worth kind of having to think about data types and binary. So an integer in Python is stored using 4 bytes, and that's going to be that'll be signed, which means it will be both positive and negative. In some lower level languages, you can actually specify the size of your integer values, for example like C++. And also some other languages which are a bit higher level like Java. So bytes is going to be 8 bits, short is 16 bits, integer 32 bits, a long is 64 bits. A little practice for your binaries to work out what the large. So we're going to look at 2 ways of doing negative numbers in this short video. One is called sign magnitude, the other is 2's complement. They are very different and they work differently, so it's important that you know A, the difference, and B, how to use both of them. Okay, it's really important you don't get them confused. It's an easy way to lose marks on the exam. So let's start with sign magnitude. Now sign magnitude is almost identical to normal binary, however the bit on the left hand side gets swapped out and replaced with a positive negative bit. Okay, so in this example we've got the number positive 34. So if there's a 0 at the front, then that's going to be a positive number, and if it's a 1 we say it's a negative. Okay, so that is it. That is sign magnitude in a nutshell. So we just replace the most significant bit with a plus or minus. So here is an example of 34 as a positive number and negative, and notice that the positive 34 here has a 0 at the front, so that's the positive number, and then this one has a 1 at the front, so that's the negative 34. As soon as we start to use negative numbers, we have a problem with the range of numbers that we can store. The problem is that effectively we halve the number of values we can store, okay, because we have to use half the binary combinations for negative numbers. So the biggest number we can store is going to be 2n to the minus 1 minus 1, and the smallest number is going to be negative 2 to n to the minus 1 minus 1. Okay, so effectively halving the number of possible values. So in this case, the largest number we can store is going to be plus 127. And then the smallest number is going to be negative 127. There are a couple of issues with sign magnitude. One is that we get a bit of a perverse situation where we have a positive and negative 0. So at the bottom, I've got 2 examples. Okay, this one on the right hand side is 0. Okay, and because it's got a 0 at the front, that's plus 0. However, this number is also 0. Okay, but it's actually negative 0 because there's a 1 at the front. So we get this weird situation where we have a positive negative 0, which makes no sense because there is no such thing. There's also another issue with adding. Okay, you can't add sign magnitude correctly. Okay, so when you look at binary addition, you can maybe work through this example. But for now, you just have to trust me that if I did minus 40 plus minus 24, well that gives me minus 64, but however doing the addition above using the rules of binary addition, I actually get plus 64, which is completely and utterly wrong. I also get overflow, but that's something else entirely. So we can't add sign magnitude together properly because it just doesn't work, which obviously is a big issue. So we're now going to look at another way of doing it, which is 2's complement. Now, 2's complement is a different way of storing binary. Some people do struggle with it. So we start off with this thing. So again, the first bit is a positive negative bit, effectively. So if there's a 1 on the front, we know the whole number is negative. However, rather than just simply reading it off like we did before, we actually need to do an operation. So we need to invert the bits. So that basically means swap them over. So a 1 becomes a 0 becomes a 1. So you can see that 0 has become a 1, that 1 has become a 0, 0 becomes a 1, all the way over. And then we add 1 to it. So if I add 1, this bit here sets to a 0, and then I have a carry, which gives me a 1 there. So I end up with this number. So that is 22. But because I've gone through this process, I actually just say it's negative 22. So 2's complement, there's a little bit more work to do. If there's a 0 at the front, then we do nothing. Okay, we just accept the number as is. So it's only when there's a 1 at the front we do something different. And it's based on this number wheel. So as I go round this way, you can see the numbers increase this number. So 1 is 1, 2 is 2, 3 is 3, and so on and so forth. However, if I go this way, I start off with 1, 1, 1, and then I'm effectively subtracting 1 each time. Okay, so that minus 1 becomes that, which gives me minus 2, then minus 3, and then minus 4. But we do have, as well, one extra negative number. Okay, so you can see here, I've got a range from 3 plus 3 all the way to minus 4. So one extra negative number. So let's actually look at another way of doing it. Okay, this is my preferred method because I find it a bit quicker than adding 1. Okay, so what you do is to work out what negative 38 is. You write it out in binary first, like that. Then you copy to the first one and then flip the rest of the bits. So I start going from this direction. Okay, so I've got a 0 there, so I just copy it. Then I've got a 1, and I just copy that. Now I've found my first 1, and then all the rest of the bits are going to flip. So 1 becomes 0, 0 becomes a 1, 0 becomes a 1, and so on and so forth. Okay, that then here is minus 38. And if I did it the other way around, okay, so copy the first 1, which will give me 0, 1, then flip the bits, I'm going to get 1, 0, 0, 1, 0, 0, which is exactly the same as that there, and we already know that's 38. So here's the time to have a little bit of a practice. So convert the following numbers into 2's complement. Okay. I suggest using the bit flip method, or if you want to, you can use the other method, which is adding a 1. And here are the answers. Do practice with those and see if you're getting the same answer.